welcome to the Absolute Recap Biology Edition. I'm your host, Melanie Kingett, and I'll be your guide to scoring a 5. Here at the Absolute Recap, we aim to maximize your understanding and minimize your need for memorization. Each episode will review content, skills, and test-taking tips to help you succeed in May. Your recap starts now. Hi, and welcome to the Absolute Recap Biology Edition. Today's episode will recap water chemistry. Let's zoom out. Water chemistry is in Unit 1, The Chemistry of Life. Topic 1.1 is titled Structure of Water and Hydrogen Bonding. The big idea for this topic is systems interaction. Let's zoom in. Like really far in. We're talking elements. What influences the chemical behavior of an atom? Your understanding of this question is going to connect to many concepts in molecular structure and function. So take a moment. Draw and label a water molecule. On your notebook, a whiteboard, chalkboard. What does it look like? Why is it shaped like that? How might that shape influence the way that water behaves? All right, so what influences the chemical behavior of an atom? And consequently, the chemical behavior of water? Good old H2O, 2 elements of hydrogen for every element of oxygen. If you look at the structure of water, it's bent. Not quite 90-degree bent. Oxygen has 8 electrons, and they're organized into 2 rings. Remember, electrons are the subatomic particle that influences how elements interact with other elements. Hydrogen has 1 electron, and so it will covalently bond with oxygen. When hydrogen bonds to oxygen, it does so in a way that forms a Mickey Mouse shape. It really is the best analogy. What happens when hydrogen bonds to oxygen in this Mickey Mouse shape concept is it causes 4 of oxygen's electrons to huddle off to one side. This gives water polarity. Well, what's polarity? If you think about the way Earth has 2 sides or 2 poles, that same concept is true for water. Water has an uneven distribution of charge. Water itself is not positive or negative, but the oxygen side of the molecule is what we call electronegative, whereas the hydrogen side of water is electropositive. Because water is polar, it's going to interact with other polar and/or charged molecules in a very specific way. So you have your drawn water molecule. Now let's label its electronegativity. We have delta negative on the oxygen side and delta positive on the hydrogen side. So draw another water molecule right next to the first. How are they likely going to interact? Well, if you have familiarity with your chemistry background, you know that opposite charges attract. So we're going to form a hydrogen bond between the hydrogen of one water molecule and the oxygen of another. The most common hydrogen bond is with nitrogen, which means that if water interacts with, let's say, ammonia or NH3, it's also going to form a hydrogen bond between the positive hydrogen and the delta negative nitrogen. Hydrogen bonding is the foundation by which water molecules interact with other things. When we look at water molecules as a collective, we'll find hydrogen bonds forming between 2 water molecules and polar covalent bonds forming within water molecules. So let's predict. How is it advantageous for different biological functions to have molecular bonds of different strengths? Hydrogen bonds are really an intermolecular force, whereas covalent and ionic bonding are significantly stronger. Hydrogen bonds are weak, but that means that we can easily form and break them. One of the big buzzwords with water are its properties, which essentially means what are some behaviors that water has based upon its chemical structure. The 3 big properties of water you need to know for the exam are cohesion, adhesion, and surface tension. Let's look at cohesion and adhesion. Those words sound so much alike and are really easy to confuse with each other. They both begin with different prefixes, co meaning with, and ad meaning to. So to adhere to something means you're sticking to something else. To have cohesion means you're sticking to yourself. So if we take that basic concept and apply it to water, the same will hold true. Water likes to stick to itself, cohesion. It also likes to stick to other things, adhesion. Both cohesion and adhesion give water its remarkable ability to defy gravity. Let's think of some examples you might know. Plants are growing in the ground. Water has to go from the roots to the shoots against the force of gravity. How is this possible? Water has adhesion to the walls of that vascular structure and cohesion to itself. In that way, it has a barrel of monkeys quality, in which each water molecule pulls up against the water molecule below it, allowing it to defy gravity. You've also seen this effect in a graduated cylinder in class. If you look at the meniscus, or the bottom curve in a graduated cylinder, water almost appears to jump up the sides of the cylinder because forces of adhesion are stronger than cohesion. If you've ever seen a droplet of water on a waxy surface like a leaf or even on the top of a penny, water forms a bubble. Water cohesion gives it this remarkable surface tension. Boiling water has to break those hydrogen bonds in order to cause the water molecules to move more rapidly. It's also what causes certain insects to have the ability to walk on water. The interaction they have with the water is not stronger than the surface tension or interaction of the water molecules themselves. So water exists in its three states. We have our gas, our liquid, and our solid. But because of its hydrogen bonding, it has different properties in each of these states of matter. In liquid water, hydrogen bonds are continuously breaking and reforming. However, when water freezes, the hydrogen bonds become more stable, and the water molecules get pushed farther apart. So this is why ice floats on water. The water molecules are more spread out and are therefore less dense. Here's a fun fact. Ice is technically a mineral because it has all of the properties that other minerals have. Minerals are natural inorganic solids that have a definite chemical composition and crystalline structure. Water is a key player in two of our basic chemical reactions. The first is dehydration reactions. Dehydration reactions are used to join monomers together and form a larger polymer. Dehydration, to dehydrate, to take out water. So if you look at two monomers adjacent and you want to link them together, you can pull a hydroxyl or an OH off of one monomer and a hydrogen off of the other. By pulling off HOH, you get H2O. The electrons left over on those monomers are now available to covalently bond together. Dehydration reactions have another name. They're often called condensation synthesis. Condensation synthesis. Also named because there is condensation, or the collection of water when something is being synthesized or put together. The other type of reaction that heavily involves water is hydrolysis. Once again, we have a name that describes the function. Hydrolysis, hydrolysis. Hydro involving water, and lysis to break or cut. So in this instance, we are breaking a polymer into smaller monomers. We are using water to cut or break this apart. When that occurs, we stick a hydroxyl onto one monomer and a hydrogen onto the other. And in that way, the bond has been broken. We're going to see the suffix lysis come back in other units. For example, cytolysis will be the bursting or cutting up of cells. To recap, water. It's pretty great. Its polarity has a direct correlation to the different functions that it has. Those functions are cohesion, adhesion, and surface tension. Water is going to have a really big role in later units, involved in both breaking and forming bonds, carrying electrons from one process to another. We are, as living things, water-based life forms. Today's question of the day is an FRQ format. Describe how the properties of water contribute to maintaining homeostasis. For the answer to today's and future questions, please follow us on Instagram at TheApsoluteRecAP. That's the APsolute recap. If you are a student with questions or a teacher with suggestions, we'd love to hear from you. If you have a biology topic or another AP subject you would like us to cover on the Absolute Recap, please email us at TheApsoluteRecap@gmail.com. That's the APsolute recap@gmail.com. The Absolute Recap is produced by Brad Kingett with music by Zach Caruso. Please remember to rate, review, and subscribe wherever you get podcasts. Time's up, pencils down. Thank you for listening to the Absolute Recap Biology Edition. AP is a registered trademark of the College Board and is not affiliated with the Absolute RecAP. Copyright 2020, Absolute RecAP, LLC. All rights reserved.